So we're going from grams of our fool's gold, or iron 4 sulfide, to grams of our sulfur dioxide to try and find our limiting reactant. All right, molar mass of iron 4 sulfide is 122.5. Okay. 119.8, or about 120 grams. If you put 120, it's not gonna be the end of the world. Okay. And then our molar mass of sulfur dioxide should be 64. All right, so how many grams of sulfur dioxide does that give us? If we multiply across the whole top, divide by the whole bottom.
23.1.
23.1 grams of SO2. Okay, so that gives us our first amount of product that could be formed. Now we need to start with our other starting compound and find out how many grams of sulfur dioxide could be formed. Is it a big deal that it starts us in moles instead of grams? No, it takes out a step of our T-chart, so it makes it a little easier for us. Yep, it's easier. Okay, so we're going to start with 1.05 moles of O2. Is that too small? Or, okay, all right, because I'm going to have quite a bit of room. So here in our T-chart, where do we go from moles of O2 next?
To the mole ratio.
Yeah, exactly. That just goes right to our mole ratio step. So we'll go mole of O2 to mole of SO2. All right, and there comes our mole ratio step. So if we multiply across the top, divide by the bottom, we get how many grams of SO2? 48.9 grams of sulfur dioxide. So which of these two is our limiting reactant?
FeS2.
All right. So which is the limiting reactant?
Iron sulfide 2.
Yes, because it gives us a smaller amount of sulfur dioxide, which means iron sulfide is our limiting reactant here. Okay? So if we put in the 21.63 grams of iron sulfide, we should get out 21.6 grams of sulfur dioxide. That automatically gives us the mass of one of our products, okay? Because all that iron sulfide is going to run out. We're going to form 23.1 grams of sulfur dioxide. How do we find the maximum amount of mass of the other product now? Same thing, but we only have to do a T-chart with our limiting reactant. It doesn't do us any good to find out how much could be made from starting with the 1.05 moles of oxygen, because that's not our limiting reactant. We're going to have excess of that. So in order to find our second amount of product, we need to use our limiting reactant, which is iron sulfide, the 21.63, and now we're going to go to our other product. Okay? So now we need to do a T-chart from grams of FeS2 to grams of iron oxide. Okay, that's going to give us the amount of iron oxide that can be formed from our amount of iron sulfide we start with. Okay, so now we're going to start with 21.63 grams of FeS2, and we're going to go to iron oxide this time. We get 165 for our molar mass of iron oxide. 160, okay. I apparently can't do that today. 55.8 times 2 plus 48. Yep, you're right, 160. Okay. So now we're trying to find out how many grams of iron oxide could be formed, which is what? 14 point what? All right. So now in our problem, we have answered, oh my goodness. Okay. In our problem, we've answered what mass will be the mass of each product. We've answered what the limiting reactant was. We have one final thing to answer, how much excess was present.
What does that mean?
Okay, which of our reactants was in excess?
SO2.
Which of our reactants was extra?
Oh, the oxygen.
Oxygen, because this was our limiting reactant. So that means we had extra oxygen. So now we need to compare how much oxygen was used during the reaction to how much we started with. Okay, so we started with 1.05 moles of oxygen. We want to find out how much was used up during this whole reaction when we used up 21.63 grams of iron sulfide. So guess what that means?
The T-chart?
Yeah. Okay, so now we have to go from 21.63 grams of this to grams, or to really just moles of oxygen, because we want to compare our starting amount to how much was used during the reaction. So we can stop at moles there if we want. We can compare it. Okay? So let me clear out some room for me here. All right. So now we're comparing our two starting reactants, 21.63 grams of FeS2. Can somebody remind me what that molar mass was? 119.8. And here, since we want to compare to our starting amount, which is in moles, we can just stop at moles in our T-chart. If our starting amount was in grams, then we'd go another step to grams. Okay, so our used up amount of moles of oxygen in this case is what? 0.5 moles of O2. So what this value right here tells us is that during this reaction, when all of this gets used up, we use up 0.5 moles of O2. Okay, so now to find out how much excess we have, we're going to take our 1.05 moles of starting minus our 0.5 moles of O2 used up, and we get 0.55.
That's way too much work for one problem.
That's how much oxygen that's left that hasn't reacted. Okay, it's left over as pure oxygen. Okay, it did not take part in the reaction whatsoever. Okay.